Okay, so for everyone who's watching, welcome to another Streaming Stories panel. Today we'll try to find out if unified batch and stream processing is the future of data processing. And with us today, Santona Tully, Head of Data at Absolver, Zhenzhong Xu, former CTO at Claypot AI and former VP of Engineering at Voltron Data, and Rais Pasha, CPO at Rising Wave. Welcome, everyone, and thanks for accepting the invitation to be today with us. So before I give you the floor, just let me remind you of some housekeeping items. The session will be recorded and shared with everyone after the event. If you have any questions, please use question and answer tab to answer the questions. And if there are any issues which we are experiencing now, please let me know. So the floor is yours. Please introduce yourself briefly. Anyone can start. Raise, raise your kind of self, like almost like a host. So maybe you can start.
I didn't want to hog the the time, but anyway, I'll do a quick introduction for folks who are probably are aware of me, who attend Streaming Stories. I lead the product team at Rising Wave Labs. Prior to Rising Wave, I've been all life around professional life around databases and big data technologies. I started out as an engineer at HP, working on database optimizer, and then I moved on to product management. And as I said, the when I started out, we had was more like traditional relational databases, and then we've gone through this whole journey of different data models and different ways process the data in at Rising Wave. We're actually sort of a hybrid where we're trying to do the same traditional SQL-based data processing, but with an engine that's built for incremental processing for streaming data. So in a way, it's come a full circle for me in terms of my professional journey. Regarding this topic, I think we did this topic last year too, but I think Redux is pretty timely here because this is a space like especially unified data processing has seen a lot of improvements in the last 12 months. So I think I look forward to a good discussion with Santona and Zhenzong.
Thanks,
Antonio,
Ray.
want to go first or want me to go first? Okay, cool. I can go next. So thanks for the intro. I go by Z. I've been in the streaming space for the past like decade or so. Being involved in a few different things. So at Netflix, I was working on the real-time data infrastructure. Managed the entire Flink fleet, Kafka fleet, and also Mantis fleet. Involved in kind of building solutions for operational data and as well as for analytics data, right? So after that journey, I was super interested in connecting the underlying data infrastructure, especially the real-time data infrastructure with machine learning space. So I co-founded a company called Claypot, really focused on doing real-time feature engineering and real-time model performance monitoring, leveraging the underlying real-time data capabilities, right? And then after that, the company got acquired by Voltron Data and moved into the space of trying to leverage GPU acceleration and also the composable data ecosystem to push this space forward, both for analytics and machine learning as well. So still super relevant to me, and super interested in connecting both machine learning and the infrastructure space. And also looking forward to learning from all of you here.
Thanks. Antona?
Yeah, relative to these two, I'm newer in some ways to streaming, but so yeah, I'm Shantana. I work as the head of data at Absolver, and I got started with a combination of streaming and batch data as well, as a physicist over at CERN. So, it's always been sort of separate. You have the data engineering where the data is being produced at like petabytes per second, and you have to have that pipeline ready that's able to process the data in real time. And then there's the, okay, now we have these, hundreds of terabytes of data that we've cleaned up for analysis, which you know, in industry might be called analytics. I don't know. But and then, you know, working on that as well, sort of in a more batch environment. So that the separation of the two has always been like it's sort of sometimes a necessary evil, sometimes a annoyance. So I think over the years, especially at Upsolver, sort of the idea of unifying them, the methods of unifying them, what can we do to sort of bridge the gap between folks who work with streaming data and folks who work with batch data has been top of mind for me. So yeah, right now I'm helping put together an Iceberg Lakehouse where we do streaming data ingestion. And yeah, we also take a sort of micro batch incremental approach as well.
Okay. So thanks everyone for the brief intro, and let's deep dive into the topic. So maybe we can start with some general thoughts about why unified batch and stream processing is important, why it matters. So we can maybe start from the architecture angle. Or you can pick your own angle, but just like to steer the discussion. What do you think, how does unified processing contribute to the reduction of architecture complexity? You know, maybe to start from that.
Yeah, I think I mean the case for unified data processing has been there for a while, right? People have made a lot of arguments, and it's self-evident. Like, you know, you have a simpler architecture, you deal with a simpler systems as opposed to have you know, multiple systems for multiple workloads. But the challenge has always been the technology maturity. Can they deliver, right? I think we are on that moment now. A lot of the architectural trends are moving towards where there is parity in terms of workloads on the streaming side that allows you to make that argument that if you have a streaming first architecture, you cannot address every workload, but you could address sufficient enough to go towards a unified approach. And Kappa architecture and, you know, you shift left sort of mold that people are talking about in terms of architectural trends, they're all pointing to that. And to me, the real benefit is obviously both from the CapEx and OpEx perspective, you have benefits, right? Operationally, it's much simpler to manage. And from a CapEx perspective also, you know, you don't have to have multiple systems. And the streaming as an architecture allows you to amortize the cost of processing throughout, as opposed to having large systems that run from time to time. Now, I'm not saying it's a panacea for everything. You're not going to do everything with streaming, but it does allow you to, one, simplify your architecture, and your cost-wise, you're basically trying to find ways to optimize that as well. So I think those are the two key vectors that I feel would help. But still, I think this is a journey. This is not where we can claim that this is set. And proof of that is, like, for example, even traditional systems like Snowflake, Spark, they're all building capabilities. Even Google, all are adding those capabilities to how they can augment their traditional batch processing to involve streaming all the way from earlier it was just ingestion, now transformations and even querying. They're going towards a streaming first approach. So in the sense, what Rising Wave is doing the other way, where we're starting with streaming and trying to address more batch use cases through a batch engine. But the goal is both, at the end of the day, can we do as much as possible from a single system as opposed to having this bright red line between these two, batch versus streaming. And that, I think, is, at least there's a consensus forming.
Thanks, Race. Who wants to go next?
I couldn't agree with that more. So just 2x that. And I think the coming from the use case angle is extremely important. So I know Z has been thinking about sort of ML use cases. I've worked in ML as well as analytics, and I think I like to come at it today more from an analytics use case side, because traditionally that's the field that has been more disenfranchised, if you will, from the streaming data sources. So it's this unification, because, as ML engineers, you sort of oftentimes, at least from the online inference side, you have to be able to work with the streaming data. You don't really have a choice. But I think analytics has been done a disservice by thinking about sort of the data sources as like, oh, this is my, CRM data from this SaaS connection, or this is my, Airflow deck that's going to run, and the things are going to come in a batch, and sort of been left out of actioning or turning the data actionable from the true sort of streaming sources as well, like message queues and databases, operational databases. So for me, like the problem that I am solving or hoping to solve is how do I enrich my analytical environment, my analytical platform with the streaming data that can help make better decisions without like making someone feel like, oh, this is, like I have to now go and learn something that is totally outside my comfort zone. I have to work with, streaming engineers to bring in this sort of data.
Yeah. I'll add a little bit more. I agree with both, Santona and Ray's points here. Maybe adding a little bit more, couple more points on both the architecture perspective and also the use case perspective here, right? So from the architecture point of view, it's really like what is the benefits for addressing that for the builders, right? So I feel like there's one important perspective change happening in the last like few years, right? In the beginning, when streaming just came out, it really promotes itself as something as a superset of a batch, right? So there was intention of building a second system to replace batch eventually at the end of the days. But I think over the years we have learned that's definitely not the case. It's not evolving towards that. But as a consequence of that initial thought, right, there's been second system effect. Systems have been built in silos. The world is not moving towards like moving from batch use cases to streaming or vice versa, but looking for a world where both systems can work together, right? So there's implications around how existing systems that has been built. We need to move towards that vision, right? So maybe let me kind of take a stab at what are some of the layers where I can promote a little bit more kind of conversation here, right? So I feel like we can break this down to a few different layers. One is on the management layer, where we're talking about today. There's a batch data set, there's streaming data set, right? It's not unified on the catalog level. There are some steps towards that, but it's not fully solved, right? So there's opportunity in that space, on unifying metadata, given the end users having ability to look at lineage, for example, holistic view, right? So similarly, orchestration is another field, right? So there's batch orchestration, there's streaming orchestration, because their life cycle is different. Batch is more ad hoc, streaming is long running, right? So how do we can consolidate some of those things together to give user a single view of the world, right? The second layer is the language layer, the access layer for the user, right? So today, obviously, there's different SQL dialect, there's different access API points, there's Python data frame, there's SQL stuff, right? There's hundreds of different things out there, for people to choose, and it's very confusing to people, right? So there's also opportunity in that place to unify. The third place, which is the compute optimization and state management, right? So where this is a layer that involves like different engines, how can things work together? How can we enable, from logical plan to physical plan, interpretations? How do you, kind of define standards, for different engines to work together? There's also opportunity for that. Finally, there's storage layer. People are looking at Iceberg, Apache Arrow for moving data. There's obviously opportunity in that space as well. The final layer I would say is the hardware layer, right? With evolution in the GPU space and network space especially, right? So we're now seeing 100 gigabits per second network, which enables faster processing. So mini batches becomes much plausible than before, right? So those are the points, maybe can prompt a little bit more discussion. Like we can talk a little bit more about the toolings and all that, right? But I also share a little bit more on the user perspective side. I feel like what's prompting for the unification on the user use cases perspective is more around there's more hybrid use cases coming up these days, right? So for example, there's IoT, there's personalization, fraud detections, and dynamic pricing. If you look specifically into some of those use cases, right, you would notice a lot of the query are exactly the same, but applied to different time range. I'm just gonna take an example here, right? So for example, for fraud detection, some critical company will implement a feature that look at the average distance between your, for your credit card swipes in the last 30 minutes, right? But they can potentially apply the same query, to calculate the average distance, for the last 1 year. It's exactly the same query, but the stage and scenario is different. That will potentially leverage, different technologies there, right? So there's a need for that. Another similar thing there is, there's a consolidation of query patterns that's emerging right now, right? There's ad hoc point retrieval, ad hoc aggregation, pre-compute, for batch and stream processing. There's also the reverse ETL for moving data back, to the client for experimentation, right? Again, it's similar. It's exactly the same query, but applied in different scenarios, applied to different roles. There's opportunity for unification in that space as well. So that's all I wanted to say. Yeah.
Yeah, one thing I want to add with what Z said is, especially in terms of the ad hoc versus continuous, right? So that line is also sort of blurring because the use case you mentioned about a fraud, like the what if scenario of going back in time and trying to recompute. Like we have a customer who's has this specific use case, like basically a time travel sort of a feature requirement to go back and recompute the model based on what the data looked like at that time, right? So the systems right now, the definition of what streaming system itself has sort of morphed, where it's not sufficient just to say, simple use cases of joining two streams and then computing some very simple metric. That's no longer sufficient, right? People want something more sophisticated where they want almost like a hybrid where you can store data for longer term, so you can go back in time and try to experiment with data, and that requires you to have a lot more capabilities built into the product. Like the first generation swing systems were great at doing those simple use cases, like you had those Samza, Storm, and then Flink came along and all. But now with the longer term retention, you almost have to standardize on storage, standardize on temporality of data, like how you store data and how do you go back in time. And those are all some of the things we wrestle with even as a product, like how far do we go, right? We don't want to supplant what the batch guys do because then we're reinventing the wheel. What is that path that kind of straddles in between, and then you're able to, do streaming first, but also try to address some of these other use cases. And I feel like a lot of the architectural complexity will come down not from these individual systems by adoption of common standards, like when it comes to Iceberg, when it comes to a common catalog, common API. Like for example, Postgres has kind of become sort of the de facto standard on the SQL side. Now, like where in Kafka, as like on the ingestion side, like all vendors use Kafka standard API, and they may have various implementations, but they are trying to rally around some sort of. So the more of that happens, the complexity sort of automatically, at least for the end user, comes down, right? I mean, we don't have to have our own extensions. So I feel like that process is underway, and all vendors, including Rising Wave, I think are looking for those patterns so that common over custom sort of becomes the norm.
Yeah. Okay, I was thinking of having like a dedicated part to discuss like storage formats and but like before we move to that, can we like deep dive into something that Ziv mentioned, like just like deep dive into some tools that support unified processing? I think we have a Flink person here, right? Wave person here, or I'm mistaken. So maybe we can start from, like how, just like discussing a bit how these stream-first architectures in Rising Wave and Flink differ in handling stateful computation compared to, for example, Spark's batch-first approach.
Yeah, I don't want to make
Person
this.
or Flink person. I don't know if I'm mistaken for Z.
Oh, you talking about Flink? Yeah. Well,
Yeah,
I work with Flink a lot, but I wouldn't consider myself a Flink person. But anyway,
sorry.
I can start. I think, if we follow the same framework, I used before, right? So breaking down at, the catalog level orchestration, on the data management piece, there's certain toolings, involved in there. There's also the language access layer, we can talk a little bit more there as well. there's engine itself, right? So, I think Flink is pretty common. People probably, who are here are familiar with, the engine internals there. So probably don't want to kind of get in too much there. So I can also talk a little bit more about, the storage network and hardware's impact on stream processing as well, right? So, how is that? The general question, if I'm not mistaken here, is how is the entire kind of streaming first architecture different from the batch oriented, kind of architecture, right? So I would say on the catalog side, there's new things like Data Hub, right? So Databricks Unity catalog, which there's also many other things like Atlan, which essentially kind of building the catalog for both streaming and batch data sets, right? So what that means is it's not really kind of distinguish between because of the table string duality, right? So tables are strings, strings are tables. So there should be a way to kind of manage both streams and tables unified in a single catalog, right? But the real important question to answer here is what is the difference between the streaming data set versus batch data set that's managed in the catalog, right? So in my opinion there, the batch data set is relatively, more stable, more longer term. It's more kind of append-only operations. For example, Iceberg, right? You can have a table and keep appending to that table. So is that a string or table? It's both, right? So for stream processing, it's more for like intermediate sort of a pre-compute, right? So where the computation query and you want to do that computation ahead of the time instead of doing ad hoc query similar to to OLAP systems. So for that, it's really about transformation, right? In machine learning space, it's like it feels like linear transformation, but in analytics space, it's joins, aggregations, all that kind of stuff, right? So things are changing. The shape of the data set is changing itself, right? So that's sort of the intermediate, move between the two more permanent data set, right? So that's how we can kind of structure the data catalog. So obviously, there's underlying things around, lineage management, schema management, metadata versioning, all that kind of stuff involved in there, right? There's a lot of opportunity for reducing cost if we're following that approach. Because today, if you look at especially large organizations, people, there are different roles and different teams, managing different data set. And often there's a lot of redundant data, right? Being computed, right? So if we track lineage and being able to manage, evolutions of the schema itself, there's a potentially, reduce a lot of cost from that perspective on bringing batch and streaming together. Originally, maybe a couple of years ago, we talked a lot about, using streaming can save a lot of money for organizations, but seems like, this is a newer thing here, right? So that's on the management abstraction layer. On the language side, as I alluded earlier, right? So there's Python data frame, Spark, has its structured API. There's the PySpark stuff as well, right? Underneath the hood, there's a SQL layer, but under there, there's still, a lower level API, right? So that, introduces a lot of confusion to people. So I think there's a common approach today where, on the machine learning side, how do we kind of leverage data frame, to give data scientists that capability to access the underlying kind of computation framework without having to change their toolings, right? So there's opportunity there. So I worked on an open source software called IBIS that can potentially, I think, Rising will also, integrate with IBIS as well, right? So that is something, if machine learning engineers or data scientists want to give it a try, it's available there, right? So underneath the hood, the magic is to translate Python logic into intermediate representation so that can be applied to different engines there, right? So that allows some sort of kind of unification there. Maybe I take a stop right here, because I talked about two different pieces. I would love to hear from Reyes and Santona as well.
I'm not entirely sure. So, I mean, I really appreciate everything you said, Z, but I'm not entirely sure what like going back to the question, like so okay, let me start over. So for me, the unification that we're overall talking about in this webinar, right, is about abstraction essentially. So like so do we want to dig into the different tools in terms of how the abstractions are made, such that the experience becomes like you don't really care if it's streaming or batch data? Is that where we sort of want to go into?
Yeah, I think the premise of the question was, now assuming that we are going to a unified processing model, there's two ways. Like there's streaming first architectures like Rising Wave and Flink are coming from one direction, and then you have the sort of the incumbents, which is Spark and others are there. So what is the architectural difference? What are the pros and cons? And to me, it seems like the computation model itself is fundamentally different, right? The incremental processing model where you process only the delta, where you have a continuous job running, it's a different paradigm where the arrival of the data itself will trigger computation as opposed to a user running a query to a full computation model, right? So that's sort of the extreme case of how they differ. Now, this is important because when you do stateful computation, obviously the batch is the way because that has a lot more control because all of the data is already resident. So you can use all sorts of optimization techniques to come up with the best model. But that's the data may not, with streaming, obviously your data is not all there. So you almost have to assume that the data is going to be in some structure. So you almost create these, and that's why the interface of materialized view makes sense, right? You create a materialized view that kind of processes data on the fly. And that's why it's a bit of a challenge also on the streaming side because streaming data can be bursty, can go up and down when there's no event data. And then suddenly, especially if you have a customer, a use case that where, say, a gaming use case or something where there is an event that generates a lot of match, there's a lot of events generated. So suddenly your streaming architecture has to take into account that sporadic nature of how data comes in. So I feel like on one hand, the streaming architectures are give you more uh, fresher insights, all that, but they also inherit a lot of the complexity. So in a way, that's where the challenge is with Rising Wave and Flink. Like how do they handle gracefully that back pressure and able to still maintain fresh data? Because if they cannot generate fresh insights, they're no better than batch. So why would I inherit and embark on this journey, right? So that's, I feel like, is where the critical distinction is.
Got it. Okay. Yeah. Sorry. I think in my head it's kind of a given that a streaming first architecture sort of addresses a lot of these issues, and it's kind of I do feel like we're at a place now where it's matured enough that it's well understood. Like you said the simple problems such as streaming joins or joining two streams. It wasn't simple, but it is today, and it's kind of amazing that we do call it a simple problem right now. That sort of association between two streams. So yeah, I mean, I'll definitely defer to the other panelists for going into any depth, but for me, like the event time based, micro batching, collecting of streaming data, and then doing the operations is like, absolutely the sort of process that makes sense for any sort of incremental process. I mean, with the caveat that like if your time window is a week, then you don't really need to sort of sit on that. So that at some point you go into batch. But like it really just to me honestly feels like a continuum, as you said, Z. Like a stream is a table is a stream, and I think that today especially it's not true like universally in terms of data practitioners, because I think a lot of the tooling that we're talking about and that we bring to market are for various kinds of data practitioners. So I don't think it's universally true to users yet that the like the underlying infrastructure sort of it makes sense for it to be sort of unified in the ways that we've been talking about. But from building perspective, and I think I'm sure you guys will agree, like this is a no-brainer almost, right? So I think this is why a lot of the interesting point of discussion I think is in the language layer that you mentioned, Z, where we're really, now we're talking like the interfaces come up to the language layer. Now we have to figure out how, all of these different practitioners and users are going to access this sort of underlying infrastructure that we agree sort of has to be a certain way to make the best of all the worlds. I know maybe I'm over generalizing and oversimplifying. Maybe we haven't solved, but it feels like we're sort of in a good spot right now as far as solving a lot of the streaming challenges and unifying the data.
Yeah, no, I do agree that we are, the improvements are like really as you can see, there's a lot of emphasis on new projects, like even um, vendors who are just doing streaming are now going into more processing layer, and the process, like the system that were just doing pure ETL are looking at streaming, like adding a richer library of connectors, so that you basically are trying to, the end goal at all of this is to reduce the data latency, not the query latency. Query latency is something that batch systems have done great, but how do we reduce actually the data latency? And I think that's the problem everyone's trying to solve.
Thanks, Raiz. Can we maybe continue with some discussion on the key challenges in implementing unified processing? Anyone?
Sure, I give a couple of my own observations. So again, on the language side, right? So if there's a future where you can use a single language, like standardized SQL, for example, or a Python data frame that every data scientist, machine learning engineer out there, can use, to fitting their training framework, fitting their inference framework, but able to access the low level, Flink or Rising Wave or Spark, whatever engine, that's capable of doing it, right? I think that would be an interesting word to get to, right? But obviously there's a lot of challenges in that space. I saw a couple things, I observed. One is, on the language side itself, right? So there's approach today on, using intermediate representation, right? Which is a old 20-year-old technology, which kind of evolved from the database itself, but applies in distributed, unified data world, right? So where, you can have a single logical representation, and allowing each engine to interpret that logical representation to translate into their own physical operators and, do the optimizations there, right? So there's opportunity there. But the problem with unification is streaming has time semantics and windowing semantics that are different from batch, right? So the question is how to unify a standard on that end, right? So today, another example here is, Flink internally uses something called a table value function, right? Which is a logical operator, and underneath the hood, they can translate that to, both streaming specific operators or batch operators, so they can do, unified processing within a single engine, right? In the future, that can apply to multiple engines, but the challenge with that is TVF is not a standard thing that the industry is using, right? So other engine wouldn't be able to understand, TVF, and and similarly, other standardization Flink wouldn't be able to understand, right? So having some sort of ability to unify on that front would be something interesting. It's not completely happening yet, so we took initial approach at Voltron Data. There's tools like Substrate, Gluton, allows similar approaches for this, but I feel like that's a major challenge today, and most of that is I don't think it's a hard problem to solve. I think it's mostly just need people's eyes on it and talking about it and starting conversations and getting work done in the community, right? So again, I'll stop right here, to kind of throw an idea out there.
Yeah, I'll just briefly say, like, it's super interesting and I think poignant that like the layer at which the challenges are, right, is that translation layer. Like user just wants to query, and then we need this layer that's going to translate it to either engine or the same engine that's handling two different types of data. I like, it's interesting to me because I think about this a lot in terms of like table formats, right? And in that space, so sort of in lake houses and open table format space, that's where the challenge, and it's, of course, it's related. It's not separate spaces, but that's where it is, right? Like, what is the future if we have data sort of in different table formats and the user just wants to access them. So yeah, I mean, sorry for bringing it, sort of back up from a technical level to sort of more organizational level, but like that is the challenge, right? I think it's so interesting that we've solved these like little, we solved the individual pieces, and now we're sort of, we have to figure out how we cross this this additional layer. So sorry for being abstract. The other thing I wanted to mention quickly is, you both, I think, mentioned like time travel and the catalogs and representing streaming and batch data in one place, and that's definitely something that excites me about Iceberg, is sort of it's choosing, it's making it like a lot of the time the important thing is making a decision and sort of saying this is the standard, right? So I really like that sort of the lakehouse, the modern lakehouse, is sort of choosing that this is where we're going to have the metadata that's needed to represent the data at various points in time, and in a way that you can access it from different engines and whatnot. So.
Yeah, so I think from my perspective, I mean, I think Z covered the functional aspect, right? Like the functional challenges in terms of language interface. I come from it from a more non-functional side, like HA, performance, and latency. There are unique challenges for a unified, especially if you're streaming first, because the 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 model for HA is a little different. The requirements are different because with streaming, it's always on. You don't have replicas, or you don't have the kind of architectures that were built to handle downtime with respect to batch. And because the stream doesn't stop, right? The data is continuously coming. It doesn't. It's not like so how do you address that? Like how do you make sure that the end user doesn't has a seamless way of handling failovers, and also scaling, right? Like how do you scale without downtime? Those are some of the challenges that I see adopting unified. Because if, for example, if you want banks, if you want mission critical applications to adopt this architecture, they would expect to have the same requirements in terms of RPO, RTO, right? That there's automatic failover, that there is very high availability guarantees, um, and intrinsically for streaming first, is it even possible, right? Like can we, how far can we go? And that's, I see that day to day when I talk to customers, right? Fortunately, we are not the source system. We're not the OLTP database that we can claim to be. So we are one layer removed, so it's okay at this point. But for us to really go unified, if we satisfy those non-functional requirements, then obviously that will make streaming even more valuable for certain industries. And also in general, batches for throughput, right? Like massive scale, terabytes, petabytes, you can throw at it. The systems are built to handle throughput, while streaming is on the latency side. You just typically associate that to ultra low latency. I need something in millisecond, 30 millisecond response time at most. So how do you square those two, right? Like you still want, because some of these cases may have a lot of data, right? So you almost you're forced to pick to go with the older traditional systems, right? Unless these streaming systems become mature enough to handle even high throughput with tolerable latency, so that you find that happy medium. That's I feel is another unique challenge that streaming has to solve before it can claim to at least be unified in that sense.
Yeah. I add one more point, if time allows here. While Race is talking about it, I feel like I thought about streaming. Why streaming is hard today, right? So because it's not simple, right? So I think another challenge is to make unified systems simple enough. Again, I'll give a couple examples here, right? So one is, streaming workloads compared to batch workloads has this concept called watermark, right? So essentially, when events arrive late, streaming has a way to be able to handle, late arriving data up to a point, So that's why as a user, you have to kind of specify how much watermark, latency, allow lateness you have to kind of apply, in the configuration, right? But again, that's actually differentiating the API and making things more complex, right? So if we think about this a step further, right? Is there any way we can actually remove that configuration so batch user and streaming user can use similar syntax, without having to worry about the time semantics, right? The challenge here is what? The challenge here is if we need to remove that, the engine needs to be automatically support infinite amount of allow lateness, right? So we are actually adding more complexity into the engine layer to support simplicity on the language front end, right? It's something doable. The reason why I'm bringing this up is, if we want to support infinite loud lateness, that means we need to have infinite local storages, for managing states, which is not possible in today's cloud-based technology, right? But that thing is going to change in the future. As we talked about, there's 100 gigabits of network that's available. There's remote storage you can attach, so essentially you have some way, to do that in the near future, right? The main point I wanted to kind of convey here is I think focusing on the user side of a simplicity is going to bring a lot more adoption for this unified infrastructure, and that is going to push a little bit more, complexity down to the underlying infrastructure layer.
Yeah, fully agree. Sorry, just really quickly. Infinite storage is not realistic, right? And keeping infinite state and infinite history of data. But I do think that we, I think that we're like, so sorry, I'll split it up into two pieces. One is, I think with a sort of clever architecture of data storage, we can get to a point where we have sufficient separation of the different stages of data stored. So like hot to cold to like glacial storage, right? And still have sufficient metadata and like snapshotting and information that the catalog and engine has that can become a little bit smoother without breaking the bank. But like infinite isn't realistic, but near infinite I think is. And as you said, like by pushing it down to the engine level, not only does the engine, I would say the engine doesn't have to have infinite history or time stamping or watermarking, but it should make some of those decisions for you around the trade-offs. So, and I think this is exactly what both of you were saying as well. Like from the user's perspective, it is just a query. This is what I want to know, and if my it's like approximations, right? If my number is going to change in the 5th decimal digit, like that's fine. And who is making that is like, should I be configuring and telling you like if like weight the most recent data more heavily compared to last week's data compared to last month's data and so on and so forth? I don't think so. I think your engine should be able to make those decisions for me and like make have those trade-offs ready.
Yeah, I'm gonna use this opportunity to do a shameless plug on Rising Wave because this is one of the things we try to address with scale, right? The separation of compute and storage, and on the storage side, we store the state as a checkpoint, so that when you have to because we know that the local storage is at a premium. It can only grow up to a certain point, one on the cost side, but the second to reconstruct the state when there is a crash, which could happen for any reason, even if you have to scale and add a new node, which means you have to redo this state again, rebuild it from scratch. So that's why we decided the conscious choice of actually pushing the state to the object store so that the compute becomes ephemeral. You can go away and you can start from scratch if you need be. That allows us
We do
to
the
obviously,
same. We came to
yeah,
the same thing independently at Absolver. Yeah, state
yeah.
and store as well.
Yeah. The downside obviously is that you are writing to S3 or an object store. There is a latency cost of like each time you request it's 100 millisecond round trip to read. But that if you can optimize that path length, then you get scale. You can really, because you're using S3 as your persistence layer, not like a intermediate storage for state. So that's a advantage we see day in, day out. Like when we do benchmarking, we do scaling, seamless scaling in terms of even failure recovery, instant recovery, sort of what we say. It helps, but it has its own kinks. There is latency issues. There is, especially if you have state growing over a certain period of time, the checkpointing has to be tuned so that so there's no free lunch, right? There has to be some give at some point. But at a architectural level, the fact that our system was built late, like only 3 years back, we were able to take that lesson in from others and incorporate that into architecture.
Yeah. The two thoughts come to mind. So we mentioned at least materialized views, right? The idea of having this sort of intermediate, sort of partly, I like to think of them as like partly computed, sort of, merge on read kind of entities. And then on the other side, we have like state, and where the question of where state is persisted and how it's persisted. And I think the thing that's in common between sort of both of these things is the need to refresh, right? Like your materialized views and your sort of state files, however you store your state, need to it's again, like, I mean, it's not going to grow infinitely. If it grows infinitely, you're going to run into latency issues. But it has to have the information sort of going back to infinity. So like, is this coming back, not only refreshing, but compacting, right? Like, this is what's relevant now. This is what was relevant before. And like, it's not a new concept by any means. And like, think about LLMs, right? Like, if you're trying to even in a ChatGPT or something, if you can have the same conversation and the same thread continue, all you have to do is every 10,000 tokens, you have to be like, hey, summarize all of that and keep that in mind. And then now that's one token, simplifying, but that's one token. And now I can continue to have, the next 10,000 tokens. And so, yeah, and again, this is an engine level question, right? Like, when to do the compaction, how to do the compaction, what's relevant, how do I, and persisting that data through in a way that, honestly, it should be surfaced to the user in some ways as well. Like, I've made this decision that your, stream from last year is now going to live here. So it's going to be more expensive for you to access it. So when you run a query that wants me to access all that data from last year, I'm going to tell you, hey, by the way, this is not easy for me. I can do it. This is my plan. But by the way, you're going to have to pay for it.
Yeah, I have one more point. I completely agree with what Santana means talked about there, right? I think he makes another point around, in order for a unified system to work, we need to have both columnar data format and also log format. Similar log format allows you to do compactions, right? But it's also horrible at doing serializations and deserialization. So there's pros and cons for different file formats. For a fully unified system, we definitely need things like Iceberg, to store that append-only data, allows you, to do large, range queries, right? But at the same time, we need to do transformations like ETLs and reverse ETLs. You also need that log data structure, right? Log structured data, right? So things like that. So a combination of different technologies definitely needed here. Yeah.
Thanks, Dee. Any more thoughts? Or maybe we should take a look at the questions. We have 2 questions and some more time left. Actually, 3 questions. Anyone wants to go with this one? What areas will be impacted most by unified streaming, like finance, security? A very general question. Anyone wants to go?
I can go by anecdotally, like what we have seen. I think finance definitely is one of our leading use case where the latency matters a lot. And then we also seen this other one, what I call industrial sort of manufacturing, energy. Like there's a lot of event data generated on the edge, and how do you process that, and like factory floor optimization, and there's different specific use cases, but those are the 2 broad areas where we have seen streaming really shine. But again, this is just it's to me the question itself assumes that is it specific to a vertical? No, I think the answer is no. It is a general purpose technology where you could it depend it can you can use it anywhere where the requirements are met by streaming. Yeah.
Is this clear, or someone wants to share?
Yeah, I fully agree with that. It's like, there are verticals where it's more of a natural fit, right? Or that have been using streaming data and have had to use streaming data. And I think it's often coming from that angle. You're not really even like batches the site. So I think here's the issue, right? Here's one of the issues. We've talked about many issues. One of the issues is depending on what kind of data you work with and what your use cases are, even today you're either a batch person or a streaming person. And that is the problem. So like finance, for example, and a lot of our clients are in the sort of ad tech side where, the online attribution is very important. So the, streaming joins and stuff. Those problems are fundamentally streaming first. And I think those verticals have been using some sort of streaming infrastructure, streaming language, etc. And I'm not sure that they're immediately thinking about the batch side of the house. I mean, it exists at the same bank. I mean, I think there's going to be batch data that someone else is processing. The benefits, I think, are a little bit less obvious for them because they're dealing with the streaming first aspect and sort of all the challenges that, like data freshness requirements and things like that bring. So I think the impact is going to be like, honestly, I'd say less felt, even less felt somehow. And then for folks who are more in the like batchy world of things is where I think it's going to be a little bit like, if you're talking about impact, it's going to be a little bit more eye-opening. Like, oh, wait, I can now incorporate my log data from, or my trace data, something like that. So it's sort of like, I now have this new source of information that I can incorporate to understand my user behavior or something like that, right? So yeah, it's almost the opposite of what you might expect. Like the finance industry and the ad tech industry and these stable industries have a good control of the streaming world already. I think, the surprise is more, the impact is more on the other side.
Yeah, a little bit more here. Yeah, sorry. Just real quick. I think, the way I'm thinking about this is, for streaming first architecture, there's like, for people to think about using it, there's like two prerequisites, right? So one is high freshness, continued processing, and also, it needs to be at a certain scale, right? For example, if all your data fits into a Postgres database, then you don't need stream processing technologies for it, right? So those are the prerequisites. Kind of comes down to the way I think about is, what industry kind of fits into this. Security definitely has a lot of data that requires almost near real time, sort of kind of, ability into this, right? More recently, for large language model, there's also a opportunity for, embedding ingestion, using a streaming first architecture. There's some thinking around that that's still relatively new, but those are, things I feel like could be, near future as well. Yeah.
Thanks, Z. We don't have much time. Let me pick a question that I personally like. So how do Hudi, Iceberg, and Delta Lake compare for unified batch and stream workloads? Although Iceberg is widely discussed, which format works best? What do you think?
I'll go first and keep it short. I think there's a reason Iceberg is widely discussed. I do think it is a format that works best. I don't want to go into any details right now, but basically, yeah, there is direct comparisons. And then for unified batch and streaming workloads, so it actually doesn't matter. The truth is that you can choose your one of these table formats, and they, in their own way, is going to be able to do that unification for you. And if you like sort of that's the whole thing about lakehouses, is a great unifier in many ways. Of course, big asterisks, and there are downsides as well and whatnot. The only thing is the standard is the part that matters the most. So like rallying behind one choice, I think is the thing that is going to set it apart. So yeah, I do think Iceberg is ideal. And then as far as how it handles unified workloads, right? So there's this concept of live tables, which are similar to like sort of materialized views and things that we talked about. So Delta live tables have sort of been around for a while. We do the same thing with Iceberg, so we have Iceberg live tables. So it's sort of this intermediate representation that held with the stream first approach that makes sort of queries seamless across batch and stream data sources. That's where we're headed.
Thanks. You're really running out of time, but maybe someone wants to try.
I'll be quick. Iceberg, because my heavy bias towards it, due to my own background. I worked for Netflix. What can you say?
Okay, this is a great way to end this conversation. Apologies to anyone who tried to join and had difficulties accessing Zoom. The recording will be on the meetup page, so you will be able to look what we talked about today. Thanks to our panelists. It was great discussion. And hope to see you on some other episode of Streaming Stories.
Great discussion. Thank you all.
Thank you,
Thank
everyone.
you.